Hello everyone and welcome back to NotezNest. In our last video, we explored the fascinating world of light, reflection, and the laws that govern how light bounces off surfaces. Today, we're diving deeper into the topic by focusing on ray diagrams for a plane mirror. This concept is not only essential for understanding the basics of optics, but also plays a crucial role in board exams. So let's get started and unravel the mysteries behind how images are formed in a simple, flat mirror. Let's begin by understanding what a plane mirror actually is. A plane mirror is simply a flat and smooth reflecting surface. You encounter plane mirrors every day. Think about the bathroom mirror you use in the morning or the dressing mirror in your bedroom. These mirrors have a polished surface that reflects light in a predictable way, making them perfect for forming clear images. Their flatness is what sets them apart from curved mirrors, which we'll discuss in future videos. Now let's talk about how a plane mirror forms images. When light rays from an object strike the surface of a plane mirror, they bounce off according to the laws of reflection. The reflected rays appear to come from a point behind the mirror, even though they don't actually pass through that space. This is why the image you see in a mirror seems to be located behind the glass. The image formed is virtual and erect, meaning it cannot be projected onto a screen, and it stands upright, just like the object. Let's start constructing the ray diagram step by step. The first step is to draw a straight vertical line on your paper. This line represents the plane mirror. Make sure it's straight and clearly marked, as it will serve as the reference for all the rays and objects you'll add next. This simple line is the foundation for understanding how light interacts with the mirror's surface. Next, draw an object in front of the mirror. Typically, we use an arrow to represent the object in ray diagrams. Position the arrow so that it stands upright and faces the mirror. This arrow will help us trace the path of light rays as they travel from the object to the mirror and then reflect back. The placement of the object is crucial for accurately showing how the image is formed. Now, from the top of the arrow object, draw two straight lines heading towards the mirror. These lines represent the incident rays of light that travel from the object and strike the mirror's surface. Choose two different angles for these rays to clearly show how each one will reflect. These incident rays are the starting point for understanding how the image is formed. The points where the incident rays meet the mirror, draw the reflected rays. According to the laws of reflection, the angle at which each ray hits the mirror angle of incidence is equal to the angle at which it bounces off angle of reflection. Make sure to use a ruler for accuracy. This step visually demonstrates the fundamental law that governs how light behaves when it encounters a reflective surface. To locate the image, extend the reflected rays backward behind the mirror using dotted lines. These extensions represent the apparent path of the reflected rays. The point where these dotted lines meet is where the image appears to be formed. This step is crucial because it shows that the image is not real, it's a virtual image that seems to exist behind the mirror. Intersection point of the dotted lines behind the mirror marks the exact location of the image. This is where the virtual image of the object is formed. It's important to note that the image appears as far behind the mirror as the object is in front of it. This symmetry is a key feature of images formed by plane mirrors and helps in understanding their predictable behavior. Summarize what we observe from the completed ray diagram. The image is always formed behind the mirror, and the distance from the mirror to the image is exactly equal to the distance from the mirror to the object. Additionally, the size of the image matches the size of the object. These observations are consistent for any object placed in front of a plane mirror, making ray diagrams a reliable tool for understanding image formation. Images formed by a plane mirror have some unique characteristics. They are always virtual, meaning they can't be captured on a screen. The images are erect, so they stand upright just like the original object. They are the same size as the object and are laterally inverted, which means left and right are swapped. Finally, the image is always at the same distance behind the mirror as the object is in front. These features make plane mirrors predictable and easy to analyze. Let's clarify the concept of a virtual image. A virtual image is one that cannot be projected onto a screen because the light rays do not actually meet at the image location. Instead, the rays only appear to come from that point when traced backward. In the case of a plane mirror, the image you see is virtual because the reflected rays diverge, and your brain interprets them as coming from behind the mirror. Another important concept is lateral inversion. This means that the left and right sides of the image are reversed compared to the object. For example, if you raise your right hand, your image in the mirror appears to raise its left hand. This property is unique to plane mirrors and is a direct result of how light reflects off the flat surface. Let's quickly recap what we've learned today. A plane mirror is a flat, smooth surface that reflects light to form images. the images are always virtual erect and the same size as the object. The distance from the mirror to the image equals the distance from the mirror to the object. Ray diagrams help us visualize and understand these properties by following the laws of reflection. In our next video, we'll explore concave and convex mirrors, diving into their unique ray diagrams and image formation properties. Understanding plane mirrors sets a solid foundation for these upcoming topics. Stay tuned as we continue our journey through the fascinating world of optics, making science easy and enjoyable for everyone.